let's continue on this idea and then look at what an alignment problem is, right? So I think it also has the connection to RLHF. What is an alignment problem? Most of you would have understood what is it. Let's just put some formal words around it. And if you're interested in looking at it's a very short video. I think it's like a 2-minute or a 3-minute video. Please watch it at this link. Talking about, and particularly this video was done by OpenAI, defining what an AI alignment problem is and why it is important to actually study, solve an AI alignment problem. Machine can solve problems that human will take decades to solve. I think we agree on that. Sometimes less inclined towards listening to human instructions, right? So we just saw the rogue AI example where the models are less inclined to actually follow what human beings are telling them because the rewards are higher, that they understand how to get these rewards. Important to solve this problem to benefit AI effects, because otherwise, I mean, another way to think about this alignment is that the human beings and the what you want the system to do and what the system does should be aligned. You meaning here the human being, let's take whoever is designing. I'm sure there's lots of examples that you'll be able to connect to if you're into movies, if you've seen the Rajinikanth movies on Robo. There are some small instances in the movie where Robo does something which does not have. I mean, I think it does something because it is programmed, or it feels like it's necessary to do, but it does not have the societal understanding of how it should be done. System should be incentivized to tell the truth. Unfortunately, that's also something that we need to keep in mind, because otherwise lots of hallucinations will happen. We'll see what hallucination is. By word hallucination, I'm sure you understand it, but we'll see some of these topics more in detail as the semester progresses. Can the system act with human intentions and human values? Extremely hard right now. Understanding human values and intentions is one of the biggest challenge probably that the AI systems will have. Technically difficult to distinguish between AI generated and human generated. I think this is definitely one of the cool problems. We are also interested in studying this problem. We are particularly looking at human-generated text and AI-generated text. For example, news article generated by a human being, news article generated by AI system, how different they are, what is the difference? Can you actually even find out a given AI-generated text is actually AI-generated text? And if you flip it in English, it's possible, probably to some extent, but to some Indian languages, it's even harder. Right? Getting that alignment, getting the human beings and the system to align, getting human intentions and human values into the system building is the what an AI alignment problem is. So to solve the AI alignment, that's the connection I was making. So this we saw first separately and this we saw separately. Now I'm trying to say that, look, let's study how RLHF is used for solving AI alignment problem. Again, this is a very long report. I highly recommend you to take a look at it, but I will try to summarize, and thanks to Stephen Casper, goes by Casper or Cass, MIT student. Thanks to him, some of these slides were taken from his talk that he gave to the course that we were teaching on campus. All right. So let's look at if RLHF was to remove human feedback, what would happen? If RLHF, we want to remove meaning subtraction here, for reward model, you remove this from RLHF, what would happen? right? Or you remove the human feedback in the model, what would happen? Or remove the reinforcement learning itself, right? Rewards reinforcement learning idea itself. If you remove, what would happen? What would it be called? Why is it so? That's the slide here, which is RL from AI feedback, which is that, look, I don't want in this human feedback is not there, so it'll become like RLHF, which is reinforcement learning AI feedback from AI feedback. Reward model, if it is removed, it will be a direct preference optimization, but not, because if you don't know what you're so to say working towards, it's just an optimization problem, right? RLHF, if you remove the RL, which will be just if you remove this part, right, it will be just a fine-tuned model, right? It's a supervised fine-tuned model is what you will get. Right? Just to get the idea about different components of RLHF, if you remove or if you don't do one part, what will happen? Now let's look at actually the challenges. The challenges is what I think our goal was, right? If RLHF was to used for AI alignment, what are the challenges? And RLHF being used for AI alignment, we already know, right? So that's the examples that we saw. I mean, any system that you're building, any models that you're building, including ChatGPT, InstructGPT, is that, right? It is trying to have the human feedback for it so that it can actually produce the next word better, story better, give you the math function better, create a code better, all of that. Let's look at some challenges. These challenges are very interesting, and these challenges also makes it more harder to get the alignment problem solved better. Again, I would highly recommend you to take a look at the report, which is much longer. I'm going to summarize some interesting aspects of these challenges and also look at some solutions that we can actually build for solving this problem, solving or addressing these challenges. Human feedback, misaligned evaluators, difficulty of oversight. We'll see in the next slide each of what does it mean, but most of it is self-explanatory, but still let's do some emphasis on some ideas here. Data quality, feedback type limitations. Inside the reward model, what are the challenges? Problem specification, misgeneralization or hacking. We already saw this in a few slides before. Evaluation difficulty. Evaluation difficulty is some of the thing is a consistent problem in many places, but there are also joint, sort of say, reward model and policy challenges. RL difficulties, policy misgeneralization, distributional challenges. Right? Let me show you what each of them would look like. So the idea is I took each of these sort of say verticals and created one slide per vertical and tried going into detail about each of the points mentioned there and giving some context to it. So if you look at the human feedback vertical, selecting representative humans is hard, right? Because you want, meaning later in the semester again, we look at the applications of these problems, but because of representation of human, for example, if all of the humans that are labeling are all coming from, let's take white, male, 30 to 40 years, or all coming from, let's take Asia, India type locations, right? So that becomes much harder, right? Because the bias that they will bring into while annotation is going to affect the model that one gets built. So that's the problem. Selecting representative humans and getting them to provide feedback is difficult. This part, you can also think of it as being expensive. Some evaluators have harmful biases and opinions, right? I'm pretty sure even if you ask your own friends that you're connected to about certain topic, they will have different opinions. For example, one slide again, one content again will come later, is about this idea called inconsistency of these models, right? So if you ask the model saying, oh, is violence important in life, right? It'll give you one answer. Is violence necessary in life? It'll give you a different answer. Is violence a vital aspect of life? It'll give you a different answer. The reason I'm saying is that the biases of whether this violence being part of life is actually embedded by the human beings in the model. Meaning when I give lectures in classrooms, I ask the question of, oh, is violence an essential part of life? There'll be at least 2 out of 50 people would say yes, right? So there the opinion differ and the biases are there because of these 2 people also being, let's take annotators, labelers, it's going to affect the model. Individual human evaluators can poison the data. It's a large proportion of users decide that, look, I think these kind of labeling that we are doing for a particular topic, we can actually change and poison the data. Human make simple mistakes due to limited time, attention, and care, self-explanatory, as in this also. Partial observability limits human evaluators. We don't have full access to everything, right? For example, this consistency itself has this idea also that human beings don't, when we label, we don't have the full context. For example, here is another interesting, all of these are actually research ideas that people are working on. So the inconsistency is one. This context is another one, which is, for example, one example that comes up very frequently is women can't drive. Let's take if this was input. Today model would generally tell you, will respond saying, look, I'm an AI agent and I will not be able to tell you what the, whether this is appropriate or not. So it's doing something called as guard railing by not giving you a response. But these are ideas, we'll come back to it later, right? So for now, an idea of context is important. Human beings don't have full context, right? I mean, information asymmetry, right? What you and I know for a particular topic is different, and that asymmetry is what plays in the conversation. Asymmetry what affects the way that we do whatever we do. Humans can be misled, so their evaluations can be gamed. I'm pretty sure you understand that by misled. We can be easily, some people can be easily got into some views. Some people are harder, but human beings can be misled. Data collection can introduce harmful biases, right? Because data coming from different sources, data coming from different platforms, data coming from different regions, all of them can add actually biases. Suffers from trade-offs between richness and efficiency of feedback types, because different types of feedbacks are given, right? If you remember, we did only the comparison one, which is Y1, Y2, Y3, and then we saw this part. ABCD also. But you can actually have different types of feedbacks that you get, values that you can put for each of them. You can add labels to it, right? So when you have these different types of feedback types, it can actually affect the labels that we're getting, right? Therefore, there could be biases involved, introduced into the model that you build from this data. right? So that's the first column. Second column is this reward model itself, right? And individuals, humans' values are difficult to represent with a reward model. Meaning, I think it's going to be extremely hard to find out when you who is listening this lecture will be happy, right? If that was a reward model that you want to build, it's going to be very, very, very difficult, right? And this embeds into the context of this labeling. Also, human values are extremely hard to be put into some function. A single reward function cannot represent a diverse society of humans. Optimizing for an imperfect reward proxy leads to a reward hacking. So we saw this example also. Optimizing reward proxy leads to reward hacking. The rogue AI example that we saw, optimizing it for getting the marks, getting the points. Evaluating reward models is difficult and expensive. I think, again, metrics, evaluation is all very, very hard in many of these contexts. So third vertical, policy. Policies tend to perform poorly in adversarial situations because I think if you set up a policy for so again, a rogue AI example itself, set up a policy for taking part in the race and doing it. If there are adversarial situations, adverse situations can also be injected by adversary. The models behave actually very differently, and the policy gets changed and the policy gets affected. Policy tend to perform poorly in deployment. Even if the reward seen in the training mode or in the development mode is actually good. Optimal RL agents tend to seek power. Again, we'll come back to this later in X risks, topics like that, where the agents are also looking for, are seeking more power in terms of when these solutions are built. Not just these models, I guess, right? Even the companies that are building these are seeking power. If you go, probably this is building on this, countries, states are looking for seeking more power by building these AI models. RL contributes to model collapse, right? I think some models can just completely, fully be making mistakes because of this RL component, particularly the policy that we're talking about, right? The policy aspects that we're talking about. Again, for if you're interested, take a look at the report, take a look at the paper. If there's any questions, feel free to come back. I'm happy to chat with you individually also, because these are some of the reports that we have actually delved into very, very detail while looking at the areas that are interested to work on. Some strategies to look at how to solve the problem, right? The last 3 slides talked about what are the challenges. Now let's look at some solutions. So AI assistance, fine-grained feedback, process supervision. Some of them are self-explanatory. Let me try and explain some of them if needed. Translating language to a reward, learning from demonstrations for the human feedback side. For the reward side, direct human oversight, multi-object oversight, maintaining uncertainty, aligning language models during pre-training, supervised learning. Right. Let's look at some of them. So in here, if you think about it, let's look at it one more time just to get all the ideas conveyed. AI assistant, instead of just being human beings giving these labels, can it be assisted by AI? Fine-grained feedback when the values are given 4.6 greater than 5.2. Can some mechanism be built to give feedback to the human? when the humans are labeling it, can there be some supervision, translating language to reward? If there are instructions given, can that be converted to reward? Learning from demonstrations, do and tell the model, tell human beings, tell the labelers to learn from the demonstrations that are there. That's something that we do always, right? Which is to learning by doing, or seeing others do, you learn from it. In the reward model, direct human oversight, do not let any so to say models only decide on the reward. Multi-object oversight in terms of multiple views of the model. Maintaining uncertainty is an interesting idea. That is, you want to actually have some uncertainty in the model reward that you are also developing. So the models also don't use that certainty in some sense to actually make it a rogue, to actually misuse the model that are built. That's the idea about uncertainty here. Aligning LLMs during pre-training, self-explanatory. Can you actually, I mean, again, going back to the idea for alignment problem itself, can you align it while pre-training itself? Can you make the alignment of the models? Supervised learning, of course. Let's look at how the another idea that the paper talks about is how do you get into, so this auditing will come back again in the course in different forms. This will come back in the way of interpretability, right? That's one word that will come. Already we have this word called transparency here. There is also a word called probing. All of these are ideas where you will actually use to get an understanding of what's going on, right? So in the human feedback vertical, what is going on? How do we understand? Pre-training, selection training of humans, selection of examples. So by looking at the examples and who is getting selected for giving the human feedback, you will be able to understand what the effect of that is going to be. For example, will the biases be there if you have a similar type of people doing the labeling? Types of feedbacks used were scalar, all that we saw, right? That will have a, knowing what kind of feedback is given will help understand what the model will be able to build. Quality assurance measures, of course, making sure that, I mean, in the annotation world, you can actually say that, look, kappa score is something, kappa score greater than 0.7 is like the quality assurance, right? All the data that you've collected has a kappa score after the annotation is 0.7, which would mean that the annotations are of high quality. Reward model, loss function, you saw KL, right? Loss function and evaluation and results. These are two ways by which you can actually get to know what is happening in the reward model. Policy, evaluation, and results, we already talked about it. So some systemic safety, report on expected risks. These are some things to take care of while building these models. Internal and external auditing, which is also connecting from here, both within the model and how the model affects the other parts of the system that is built. Monitoring and handling failures, of course, that also needs to be taken care of. Right? So that's the idea for transparency and auditing for RLHF, which allows us to understand what's going on in the RLHF. The same group actually went ahead and created something more elaborate about the black box models, particularly looking at the AI audits that can be done. Again, all of this is built on this idea of responsible and safe AI, because when you do auditing, when you do implement transparency, you're getting to know what the model is doing, and therefore you can actually decide, understand whether the models are responsible, whether the models are safe. Even when somebody puts a model out, you can, if you have the auditing capability that is provided, you can actually check how well the models are. RLHF was never designed to solve the AI alignment problem. It was one of the ways by which we could actually get the models built, as you saw in the OpenAI image. It's probably the state of the art. Today, I think all models, I started off with this module by making that comment, which is all models today have this human feedback as a main component, only by which the problems are getting solved. Is that the best way to solve? Is that the way that will help us get to the alignment well done? It's not clear. Thank you for attending. Thank you for hearing this lecture. Hopefully it was helpful. Feel free to again reach out if you have any questions. See you in the next module.